Welcome to the GOCO instructional video series. In this video you will learn how to complete the GOCO inputs for the header selection section. In this section we specify the header tank details. We will begin this presentation from the point of view of having started GOCO and loaded a new or existing scenario in which the parameters before the header selection section have been completed. So if you haven't started your version of GOCO, please do so now. Once the landing screen has loaded, then select New Scenario or an existing scenario through Select Scenario, or we can even import a solution. We'll select the new scenario. So this is just an example. We'll randomly select a valve and we'll just fill in a few parameters, although this is not necessary. And then navigate to the header selection section, and the first header parameter that is specified is the header volume in the drop-down list. We have a few selections available to us. We can either solve for the header volume, we can put in a known header volume, or we can calculate the header volume from the geometry of the header tank, be that round or rectangular. The header volume, if it is not known, can be solved by those parameters, and an appropriate solve mode that incorporates in the solution the header volume. In this case, the header volume will be minimized that meets the criteria of the currently selected solve mode, which we'll put to the calculate outlet and or header sizes, which is the GOCO 7.2 equivalent. Now this is set as 70% of the initial header pressure. The two solve modes that can be used to solve for the header volume are firstly that which is now selected, the calculate outlet and or header sizes, which will be a header pressure that depends on the value specified in the field under the solve mode selection box, which is the pressure percentage remaining box, which is this one here. The default and minimum recommended value is 70% of the initial pressure. The other solve mode is the full automatic, which is that one, and this also has the same criteria of 70% of the initial header pressure. However, this solve mode does not allow the percentage to be adjusted. It can be overridden if a header volume is specified in the header selection section when the full automatic mode is selected. If the header volume has been specified by the customer, then select known header volume. That's this one. The header volume may then be inserted in the given input box with the appropriate units of measure. So we can just put in there, for example, 200 liters, and we can change to different units of cubic feet or cubic meters. However, as is often the case, a comparison might be required or useful and can be made between the cases of scenarios to compare the performance of the cleaning system with different parameters. The differing performance of the cleaning systems with the given different header volumes could be a goal or a beneficial sales point for the customer. The other option is to specify the header tank by defining the header in terms of its geometry. So we can select that from the drop-down list. There exist two options in which the header may be supplied. The header geometry can be round, cylindrical, or square, rectangular, and of predetermined length. Once these input fields have been completed, the header volume is then automatically calculated. So for example, if we select our round header tank, and we can input a diameter of 150 millimeters, header tank length of 2 meters, then we see the volume is automatically calculated, which in this case is 35.3 liters. The remaining input field that needs to be completed in the header details section is the header temperature, which is this field right there. In most cases, the header temperature will not need to be changed from the default value of 20 degrees C or 68 degrees Fahrenheit. There will be cases though where the location of the header tank will be immersed in a hot or cold environment or close to a heating or cooling source, thereby raising or lowering the header temperature and of the fluid inside, namely the air temperature. The effect of higher air temperature in the header for a given pressure and volume lowers the density of the air, so for a required mass flow rate, the air consumption will be greater. The high temperature air means you need to pass more air volume to generate the same cleaning factor. To increase the air volume flow rate means that there is a need to increase the orifice size. Likewise, if the temperature of the air is lower, the density is higher and the orifice will be smaller using less air volume. It is important to note the temperature of the header, which in practice would include not only the header but also the piping feeding the header. This is a parameter that should be used if known and requested as part of the new customer GOCO questionnaire, which has a provision for temperature input of the header and the flue gas. This completes this video in the series. As always, we hope you enjoy your GOCO user experience.